its purpose and its operation. Exhaust gas recirculation, or EGR, works by recirculating a portion of the engine's exhaust gases back to the engine to reduce oxides of nitrogen, or NOx levels. Exhaust gas is diverted into the intake via an EGR valve. An external pipe can be fitted to either the cylinder head or exhaust manifold. This pipe goes from the EGR to the exhaust manifold, or it's screwed to the cylinder head exhaust port. EGR works by providing an inert gas to absorb combustion heat, thereby lowering cylinder temperatures. These lower temperatures reduce NOx. Early EGR systems were purely controlled by manifold vacuum. Now they're usually controlled electronically. EGR is used on petrol and diesel variants, as both of these engines produce NOx. There are many types of EGR valves: negatively operated, positive back pressure, and electronically controlled EGR valves. Negative operated EGR valves incorporate a vacuum diaphragm and a return spring. When vacuum is applied to the diaphragm, the valve will open, allowing exhaust gas flow. When the vacuum is removed, the spring will close the valve, blocking the port. These valves usually incorporate an internal or external thermal switch to prevent the EGR valve from opening when the engine is cold. A cold engine does not require EGR, so adding the temperature control makes the engine run smoother. Positive back pressure EGR valves are similar to the negative pressure version. This type allows exhaust pressure to push toward a spring-loaded vacuum valve via a hollow valve stem. Initially, when the valve is closed, there will be vacuum on both sides of the diaphragm. When back pressure rises, for example on acceleration, the exhaust pressure closes a spring valve and seals off the vacuum opening. A greater vacuum will now be above the diaphragm, allowing it to move, opening the EGR port, allowing the exhaust gas to pass into the intake. These days, electronically controlled EGR systems are the most common type used. They usually use a pulse width modulated solenoid or electronic EGR valves. The advantages are that the ECM can determine the most opportune time to operate the EGR valve. They are also able to monitor performance of the EGR system. The solenoid vacuum control type are pulse width modulated, or PWM. Control comes directly from the ECM and varies the opening of the solenoid valve. This creates a variable vacuum that regulates the volume of exhaust gas that is recirculated by controlling the amount the EGR valve opens. To determine how much EGR flow occurs, the PWM on and off time will vary from 0 to 100%. The ECM needs to know how far the EGR valve opens. One way to determine the amount of EGR is a position sensor to tell the ECM what position the EGR valve is in. In this diagram, the position sensor is a potentiometer. As the EGR valve opens, it will send a variable signal to the ECM. An electronic EGR valve can consist of a solenoid built into the valve that is controlled by the ECM. Another type uses a stepper motor controlled from the ECM. Electronic EGR valves do not use vacuum to operate. The ECM knows the position of the valve via a valve position sensor, also incorporated within the EGR valve. On some vehicles, there is a DPFE, or differential pressure feedback EGR sensor. This sensor can be pipe. There are two lines going to the sensor, one from either side of the EGR valve. When exhaust gas flows through the EGR pipe, there will be a difference in the pressure. The DPFE registers the pressure differential. The ECM will interpret this as EGR flow. The ECM also uses this information to vary the command to the actuator. Even though modern engines are becoming more efficient, they still require EGR to reduce the NOx levels. On a diesel engine, when the EGR valve is opened, the throttle butterfly will close slightly. This creates a low pressure area to assist the flow of EGR gases. The EGR effective operation is monitored by the ECM via the MAF sensor. The ECM will look for a reduction in flow from the MAF sensor. This will indicate the correct operation of the EGR. If this decrease in airflow is not detected, then the throttle butterfly will close a little more to increase the low pressure area in the manifold. This process will continue until the ECM determines that no EGR is taking place. At this point, the throttle will be open fully, EGR activation will cease, and a fault code will set. Engines that have variable valve timing on both the intake and exhaust cams still produce NOx and require EGR to reduce NOx levels. The variable valve timing system varies valve overlap. This can be utilised instead of an EGR valve. The intake and exhaust cam timing can be varied individually. This traps the exhaust gas within the cylinder by not fully expelling it during the exhaust stroke. On diesel engines, EGR can also be influenced by using a variable geometry turbocharger, or VGT. By changing the position of the vanes, back pressure can be varied inside the exhaust manifold. This back pressure will increase the flow through the EGR valve. Diesels will generally use a heat exchanger, or EGR cooler. This is because diesel exhaust temperatures are extremely high, especially on hard acceleration. Once the exhaust leaves the exhaust valves, the gases flow through the EGR cooler. From here, the exhaust gas is cooled, making EGR operation more efficient. Failure of an EGR valve may be caused by soot or carbon deposits from diesel and petrol engines respectively. These can cause the valve to stick in the open position, resulting in the engine running rough with excessive fuel consumption. On some systems, this will also illuminate the check engine light. Another cause of EGR failure can be a cracked or loose EGR pipe. This will produce an exhaust leak. Rough running may also be caused by this fault. That's exhaust gas recirculation. As you can see, there are many variants out there. This is why it's important to understand what type of EGR valve you are dealing with and how it works. Otherwise, misleading diagnosis could occur. Thanks for watching and bye for now.